I'll entertain the questions that you might have, but then I'm also just going to work through some problems. But I just first want to open up if there are any questions that you have before we get moving, whether on the sort of types of problems or particular problems that you might have. Or even with the OpenStax, that is, I delayed it until tomorrow. Yeah, if you're okay.
How we should study like all material coverage, or is there any specific type of problem that we should focus on more than the others?
Well, yeah, I mean there are certainly some problems that you'll have, right? Like the type of problem for the projectile motion, you'll have the type of problem where you have an object that follows this path, and I'll give you some angle, and I'll give you some initial speed, and I ask you things like, what is the distance traveled? What is x equal to? And then I'll also ask you, or I could ask you, what is y equal to? So you need to know how to work that question for sure. We've done that a couple of times where I give you v naught, say v naught is equal to, I don't know, 10 meters per second, and theta is equal to 30 degrees, or whatever, for example. So you certainly need to know how to work that problem. And we can come back and we'll work through this just for reference. And then the other type of problem is that you need to know how to do this type of projectile motion problem, where you have one that just goes off at a horizontal. That's like what y'all did in lab with a spring-loaded gun, where you need to know, I would give you y. I could have some slight variations, like I could give you x as well, or ask you to find x. But say, for example, y is equal to 2 meters, and I would give you v naught equal to, say, 2 meters per, or let's make that different. Say v naught is 3 meters per second. And then you have to find things like the time in the air, or what is x equal to. So those are types of questions that you'll need to certainly answer. And then for the chapter 4, we'll get to that later. But as far as projectile motion, you definitely need to know how to do these two types of problems. Great.
Will you give us problems where we aren't given the initial velocity and we have to find the initial velocity?
Yeah, we'll look at some old tests, and so we'll see some like that. But they're not going to, the first, out of the first 4, a couple of those problems on the OpenStax were challenging. I think they're challenging, and so I hope that y'all do too. So you're not going to have any mathematically that are as complex as that, where you have to use a quadratic, or you have to substitute one equation into another, or whatever. Okay? Any other questions? You want to jump into these? You want me to do these 2 problems? They're sort of good first step problems, and I always like to ask them. They're just sort of something that you need to know how to do for projectile motion. So here, we're given v naught, and we're given the angle theta, and I want to know x, I want to know y. And so the first thing that I want to do is find t. In order to find t, I know that at this top of the trajectory, that vy is equal to 0. And so in order to find t, I say vy is equal to v naught y plus ay t, and then I solve for t, because I know everything here but t. 0 equals 10 sine of 30. So you need to know that the y component of any vector is that vector's value, v naught in this case, times the sine of the angle 30. So v naught y minus 10, that's the acceleration, times t. And I like to put a little t top here, just so I realize that that is different from t total. And so this is 0 equals 5 minus 10 t top. And then I solve for t top. So t top has to be a half a second. But then you need to recognize that a half a second, that this occurs right here. And that 1 second occurs right here. Half a second at the top, 1 second at the bottom. That's because it begins and ends at the same location in the y direction. And then if I want to know x, I say x is equal to vx times t. Remember, in the x direction, there's no acceleration, so vx equals v naught x. So this is equal to v naught cosine 30 times t. Not t top, but it's going to be our t total, because I'm looking for the position down here. So v naught is 10, cosine 30 is 0.86, times t, which is 1 second, so that's 8.6 meters. So that's the x range. And then if I want to know the y range, I would say y equals v naught yt. Which t is that? A half a second or 1 second? Half a second is right. This is going to be t top because I'm looking for this y displacement, and at this point in space, the time is a half a second. You need to keep those straight in your mind as you're going through these. V naught t top plus 1/2 ayt squared. We haven't introduced any new equations. We just have those two kinematics equations. They're just sort of special cases for those kinematics equations. This should be v naught y right here. V naught y is 5 meters per second times 1, or excuse me, not 1 second, times 1/2 second minus 5, that's half of ay t squared, which is half squared. That's 2.5 minus 1.25, which is 1.25 meters. All right? So that's our, that is our y displacement. If we look at this, by the way, if there was no acceleration in the y direction, this thing would have gone up all the way to 2.5 meters. But because it's accelerating in the negative direction, it drops down this 1.25 meters. Now, follow what I'm saying about that? Let me draw it on the figure. It's not terribly important, but it's sort of important that if there was no acceleration, this thing would have continued on in a straight line, and it would have been 2.5 meters up in the air if there was no acceleration in the negative direction. But because there's this minus 1 1/4 that comes into play, and so it actually drops down to where it would have been. Okay? You need to know how to do this backwards and forwards in your sleep. So I would practice this, and on every test, practically every test, there's a sample problem like this. We'll look at some and let y'all try it. But let's look at this other one, which you also need to know how to do. Sorry, any questions about this before I move on? I know this is kind of fast, and I know that some of you are really overwhelmed right now. Like you just feel like there is no way out. Are you overwhelmed? Or you have a question?
Are you cover the ones where it stops at a certain point? Like take it all away?
Yeah, we'll look at that. Those are actually pretty easy. So we'll take a look at those. This one, so I was saying, some of you feel really overwhelmed right now. I know that's the case. I've talked to a number of you, and I know that a lot more of you feel overwhelmed. It's okay to feel that way, but I just want to give you some encouragement that I've seen students in that same position, and they come out okay. All right? So it takes a lot of work, and you might even need to come see me, go to the tutoring center, keep coming to the help sessions. You're going to have to spend some time. It's going to take a lot of work, but there is a way out, and it's a successful way out. Okay? So be encouraged. All right, so this one follows a similar path. First, I want to find t. But in this case, it's a little bit different. I don't find the time in the same way that I did before. I still consider the y motion, but I do it a little bit differently. I say, well, my y displacement is negative 2 meters, because I start at 0, I go to negative 2. My v naught y is equal to 0 at the top, because there's no velocity in the y direction, and ay is equal to negative 10. And so from this, I can say y equals v naught yt plus 1/2 ayt squared. V naught y is 0, so this whole thing goes away, because 0 times any number is 0. And then I can plug in the values and find t. So negative 2 equals 1/2 of negative 10, that's negative 5, t squared. T is the square root of 0.4, which is 0.63. So that's the time that it takes to go from here down to here. That's also the time that it would just take to drop. It takes the same amount of time, right, if I go from here to here as if I go from here down to here. Yeah.
Okay, this might be a stupid question, but can you explain why there's no velocity in the y direction?
So if I have something that comes off the horizontal surface like this, initially this velocity is only in the x direction. Now as soon as it comes off, it starts scooting across, it starts falling, right? But when it comes here, it's not moving in the y direction. It would have to be going up or down. But it quickly falls.
So it's just the acceleration, like the due to gravity.
Right. The acceleration due to gravity is what's causing it to drop down. That answer your question? All right, so now once we have the time, we want to find x. If you're ever looking for x, it's just vx times t. Right, that's the only way you can find x. Vx here is 3 meters per second, and t is 0.63. So what's that, 1.89? Or whatever, what is it? Let's call it 1.9 meters. All right, so you need to know how to do those two. Yeah, Mallory?
VO, is that supposed to be VX at the top, or is that?
It is both. So in this case, VO is equal to VX. Because there's no velocity in the y direction initially. And hear what she's saying? Why is that VO and VX? Why are they the same? Just a second here, let me explain that. VO is only, the initial velocity, V naught, is only in the x direction, none in the y direction. So since there's no y component, the initial velocity is all the x component. So V naught is equal to Vx. And then actually Vx remains the same throughout the entire trajectory. So if I were to draw the velocity vectors here, I would have V naught here. It would be exactly the same here, here, and here. Now Vy would be a little bit different. It would be 0 here. Here it would be small and negative, bigger and negative, and big and negative. Good question, Akira. No, that's fine. I was just trying to think about how would that impact you working the full problem, right? I'm glad. I can see it's making sense a little bit. Projectile motion is hard. I told y'all that it was easy, right? I think I told y'all it was easy. I was lying. It's hard. It should be easy because it's just kinematics, right? And you're just throwing in a little bit of vectors. But it's sort of hard to imagine. But I find it helpful if you keep your x's and your y's separate in your mind. That there's this x motion going on with ax equal to 0, and then there's this y motion going on with ay equal -10. And you know, those problems by themselves are not that hard. I mean, they're kind of difficult, but when you mash them together, it seems more complicated. Y'all want to look at some old tests and just sort of look at different types of problems that you encounter? Because you can see some different types of problems from this. Most of these are going to be on exam 2, but as we're moving forward from here, you'll begin to see that our exam isn't exactly the same. Like our exam 2 isn't exactly the same as the previous exam 2. So you'll need to sort of look at the exams before and after, because we may or may not have gotten the same material on that exam. Okay? Because we went a little faster, or we went a little slower, or the exams were just scheduled differently. So let's look at exam 2. So y'all have F15 in your workbook, right? We'll look at F14. You're not going to have any vectors. So let's go back one more year. We'll go back to 12? You got to be careful. If you go back too far, they get really difficult. Okay, let's look at number 7. This is F12. Can y'all see that in the back, Landon? Let me zoom in a little bit. Get rid of this. Can you see that? Okay. Andre, you can see that? All right. Dominique? Good. All right, so a ball is rolled horizontally off a table at an initial speed of 0.24 meters per second. I like to draw a picture, but I understand that on the test you may not feel that you have time to draw a picture. But just get a lot of practice. As you're practicing, make sure you draw the picture. It helps you to imagine what's going on. You know it's going to come down like this. And it tells us the time here. So this one's a little bit different from the one that we did before. It tells me that the time is 0.30 seconds. It tells me that the initial speed, v0, is equal to 0.24 meters per second. Oh, and by the way, that's equal to vx for reasons we've already talked about, because there is no y component to the velocity. And I want to know what is y. Okay, so I know that to find y, I'm going to have to use this at some point. Y is equal to v0y t plus 1/2 ayt squared. So I'm just going to write this down. In fact, you know, on your little bubble form, I'd write it in a little square. That way you just have those in front of you for that half of the exam. And then I can start making changes. So I know that v0y is 0. Oh, and look, I know everything here. I know that a is -10. T is 0.3 squared. And so that's going to be -5 times, is that 0.09? So 0.44. I think at this time I was having the students use 9.8. That's why it comes out a little different. If you have the time, the problem's a lot easier. It usually is. Yeah.
So just to confirm, v0y is 0 because it's falling that way.
That's right. So because it's going off, what keys us off here as to why v0y is 0 is because it says a ball is rolled horizontally. And when you read that, you should immediately think, oh, v0y equals 0. If it gave an angle, v0y equals 0. If it gave an angle, then v0y would not be 0. I'm not going to give you a problem, however. Well, I could, but I would give you the time. I wouldn't give you a problem where you don't have the time where it's at an angle. You follow what I'm saying? If I give you an object going like this, and I don't give you the time, you have to use the quadratic, and I don't know about y'all, but like half the time when I use the quadratic, I get it wrong because I just get a negative mixed up or whatever. It's tedious, it takes a long time, then I just have to go to Google, and it's like, what is that? So I'm not going to make y'all do that either. But you have to do it in lab, and you have to do it, I think, on one of the OpenStax questions. But, you know, just be careful with your A's, B's, and C's. Okay, people? Go down and look at some others. See what else we got. Can I clear this? I get rid of this. Oh, it keeps it. Awesome. Which one is the air? Is the ball in the air the greatest amount of time here? It is A. Why A? Like B goes farther. It seems like B should be the answer. I just interrupted you there. The y always determines the time. It doesn't matter about the x. It always is the y as to how long it's in the air. So if it goes up higher, it's in the air for a longer amount of time. Gosh, was that the only projectile motion I had? Oh no, I had this one too. This one's just like the one we did before, so I'm going to look at some others, all right? Which one was this one? F12? Let's look at F11. Oh, you see, we had already gotten to Newton's law, so we have to go to exam 1, F11. Oh, that was the same question. That's not very good. All right, let's go to F14. I know some of you, we were working these earlier. I'm sorry, I was hoping not to do that, but sorry folks, my thing is messed up. Okay, so let's look at some of these. A cannonball is fired horizontally at 10 meters per second. Its speed 1 second after being fired is about what? As I know, some of you, we worked this problem earlier, but just consider it extra practice. So I have a cannonball that's fired horizontally in this direction, and I want to know what is the speed 1 second after being fired. So my time is 1 second. Time is 1 second. I have this cannonball. It follows a path that goes like that, and I want to know what is its speed. Initially, it has a speed equal to 10 meters per second. How can I find the speed 1 second after it's fallen? Well, there are two components to the speed 1 second after it falls. Let's say that this is that point over here. I have an x component, vx, and then I also have a y component, vy. How do I find Vx? What is Vx in this case? It's 10, right. It's exactly what it was at the beginning, because the x component of the velocity does not change. And Vy, how do I find the y component of the velocity? Well, how do I find Vy? Right. I know that Vy changes because it has that acceleration. So I say Vy equals V naught y, which is 0, plus AYT. My pen's not working very well. Sorry, its computer is slow. And so that's equal to 0 plus negative 10, that's my acceleration, times 1 second. And so Vy is going to equal to negative 10. So now I have these two components of the vector, 10 meters per second, 10 meters per second. How do I find the net velocity, or the total speed? What do y'all think? I have an x and a y component of my vector. If I want to know v at that time, I say v is equal to what? Vx plus Vy. So would it be 20? That is an option. It's not 20, because when you're adding vectors, you don't just add the numbers. But you're right, it is Vx plus Vy, but it's the vector sum Vx plus Vy. And so in order to do that, I would say the square root of 10 squared plus 10 squared. That's how we add the x and y components of vectors, and that's equal to 14. All right? Yeah, Mallory?
So, like 10 meters per second, I know that that's Vx now, and it can't be Vy, or V not Y. Like, what is that? I'm sorry, I know that made no sense. What is that?
Y is Vy 10? Is that what you're asking?
Yeah, like when you see 10 meters per second there, like what makes you
Oh, this 10 meters per second right
at the
here?
top, yeah, like in the top.
Oh, so it's, I key this off because it says it's fired horizontally. Right, that's important because that tells me that the velocity is all in the x direction. And so Vy is equal to 0 initially. Just like we had before. If I were to draw my vectors, I have a vector, excuse me, I don't have a, I have initially, let me draw it over here. Sorry, my pen has changed. I don't know what happened. Okay. Starts here and it goes like that. Initially Vx looks like that, and then it's like that, and then like that. It never changes. But Vy is initially 0, and then it gets bigger, bigger, and bigger. And so at this point, I have Vy is equal to negative 10. And it started out at 0. After 1 second, it's at negative 10. After 2 seconds, what is Vy going to be? Negative 20. And then negative 30, negative 40, until it hits the ground. It runs out of time. Did that answer your question? Okay. All right. Can we go to another one? The 14 is the square root of 200. Because I had two vectors. I had Vx, and then I had Vy, and I wanted to know V. This is Vx. This is Vy, and I wanted to know what is V. And so I had to do the square root of the sum of the squares.
So it says Vy is negative 10. How come whenever we did the Vy was 18? Where did that go?
Right here? Right here, you mean?
Mm-hmm.
Like, why didn't it go here?
No, like I know that's 0, so if we know Vy, why are we plugging?
Oh, we didn't know Vy at this point. This is how we found Vy at 1 second.
So that 10 meters per second is just x dx.
Right. It was just a coincidence. That wasn't a coincidence that they were equal, but it just was. They happen to be equal at 1 second. Okay. It could be at 2 seconds, in which case it would be 20 and not 10, or negative 20. Yeah.
So you said, since it's shot horizontally, what about the...
Okay, so anytime you hear that word horizontally in a problem, it means that Vx is the only velocity initially. So V naught y is 0. Anytime you read horizontally, it's fired horizontally, that means V naught y is equal to 0. Okay? Great.
So does that translate to V? So if you say something was shot vertically, does that mean V not X would be 0?
Right, but you're not going to see it on this thing. But yeah, you're right, that if it's shot vertically, like, then Vx is equal to 0. Okay?
Or if it was just dropped like a free fall from?
Right. The x would be 0. Right, that's 20. Okay? All right. Let's look at some others. Give me just a second. I'm trying to fix my pen here because something's wrong with my pen. I'm just going to X this out and open this with something different. No, that's the same thing. All right. There was another problem I wanted to do. Let's look at fall 15. All right, so here I have, this is the fall 16. These are similar to ones that we've worked. Oh, let's look at number 2. So this one is a little bit different, but it's going to work a lot similar to what we've done. You kick a soccer ball at an angle of 30 degrees. It travels a horizontal distance of 8.67 meters in 1 second. What is the magnitude of the ball's initial velocity? Just take a minute and write down the things that we know in this problem. Right? I see a couple things. The angle is 30 degrees. I'm going to get rid of the options for now, just make it big enough. The angle is 30 degrees, so that's theta, right? It travels a horizontal distance of 8.67, that's what? X, right, that's for X. T is 1 second, and I want to know what is the initial velocity? What variable is it? Yeah, V naught, that V with a 0 on it. So I'll write those things down. I say theta equals 30. X equals 8.67 meters. T is equal to 1 second. And I want to know what is V naught. I don't know, I'm not given V naught X or any of those things. All right, so this one's a little bit different from the ones that we've done. Let's draw a little picture just to remind us what's going on. This is 8.67 meters. And down here, at this point, this is 1 second. That's when T is equal to 1 second. So I want to know what V naught is. Well, gosh, how would I approach this problem? Because normally, if I wanted to know something about this, I would look at the y motion. But here, since I don't know the velocity, I can't really do it the way that we've been doing it, to find the time and all that jazz. What would I do? Are you going to tell me? You're right. So usually we use the y motion. But in this case, because of the type of information that's given to us, we can use our x motion. So we say our x is equal to vx times t. And then from that, I can determine what is vx. So vx then is x over t. That's 8.67 over 1, or 8.67 meters per second. But then I have one more step, because I'm not asked for Vx, although you see B is an answer there, and so you might be inclined to stop and say, oh, B is the answer. But that's not what we're asking for. We're asking for the ball's initial velocity. I'm not being mean in that way, okay? It's just, it's a good practice in writing tests that the wrong answers are, wrong for a reason. Okay, so now I want to find V naught. Well, I know that Vx is equal to V naught cosine theta. And so 8.67 equals V naught times the cosine of 30. Cosine of 30 is 0.867, so V naught works out to be 10. All right, 10 meters per second. So I think that was D or E. So that's a similar problem. That's a little bit different. Now you probably will still see those first two, or at least one of those first two that I showed you at the beginning. So you need to know how to do that really well. But you can see some variation like this. Mathematically, it's not difficult. There were just a couple steps. There were no substituting equations. There was no quadratic. There was nothing funky going on in the algebra. But you have to think about it in a slightly different way. You want to look at the information that's given to you. Am I given X? Am I given Y? Am I given B? And then think about the approach that you'll take from a mathematical perspective, given the equations that you have. Remember the equations that we have. They're really just those two kinematics equations. Haley, just a second. Let me write these down and then I'll answer your question. X is equal to Vxt. Y is equal to V naught Yt plus 1/2 AYT squared. And then Vy is equal to V naught Y plus AYT. And then we also had that little trick where we talked about that at the top of the trajectory, that V naught, or Vy, is equal to 0, and the total time is twice that time. Haley? Why is V naught not equal to Vx? That's a good question, because in the past few questions we've been doing, V naught has been equal to Vx. Damien, will you sign in? You can just take it over there. All right. And we'll be wrapping up about 2 minutes. Okay. Oh, why is that? Why is V naught not equal to Vx in this case? That's because you're at an angle. And so in this case, our initial velocity looks like this. It's up and at an angle. And I know that because it just gives an angle. And so it has an x component and it has a y component. It's only when V naught is horizontal like this that it has no y component. It only has an x component. Whitney. We're going to say this is so easy, right?
Okay. Whenever there is an angle, that is when we have to use cosine and sine.
Right. So anytime you see an angle, you want to think, oh, I'm going to need to find the x and y components.
And if we're looking for x, it's always cosine from the origin, and if we're looking for y, it's always sine.
That's right. So always, as long as your angles are measured from the x-axis, which I recommend that you do that, this is going to be V naught cosine theta, and Vy is V naught sine theta. So I remember because it's alphabetical, x, y, c, s. But that always requires that you have your angle measured from the x-axis. In general, life is just easier if you measure your angle from your x-axis. Okay? It's easier for other reasons, like getting a good night's sleep. That makes life easier. Taking care of yourself, being safe about the activities that you do, and measuring your angle from the x-axis makes your life easier. Akira? Ooh. Yeah. Like this. This was fall 16, right? I think I might have had one here. I didn't give you the angle. Now, let me try to imagine a problem. Can I make up one on the fly? Is that okay? Or you don't have the angle? Christian? Sign in over there, please. All right. Say I gave you the distance. Say this is 100 meters. You know, it follows a path like this. And I gave you the time. T is equal to 2 seconds. Like, you should be able to do that. You should be able to tell me what the angle is for that. And the way that you would do this is you would say, well, I know that Vx is equal to x over t. Right? And so that's equal to 100 meters, that's my x displacement, divided by 2 seconds. And so it's equal to 50. And I know that Vx is also equal to V naught cosine theta. And so I would say 50 is equal to, let me make this bigger, is equal to 200, V naught is 200, times the cosine of 50, or cosine of theta. And then I would have to solve that for theta. You know how to do that? Let me show you. I would divide both sides by 200, so I get 50 over 200, or 5 over 20, equals the cosine of theta. And then I do the inverse cosine of both sides. So I do the inverse cosine, or it might be called the arc cosine on your calculator, of 5 over 20, or 1 over 4, or 0.25, and then that would be equal to theta. That inverse cosine effectively eliminates that cosine. So I have, isn't that, 1 over 4, 0.25. You might have a COS, or COS to the negative 1, is 75 degrees. That's a good example. Like that would be a good test question. I'm gonna save this and put it on the test in like 2 days, whenever we have that test. When it's coming up soon, right? When is that test? I just That's not far away. It's like a little more 2 weeks away. Okay? Okay, well, that's a great question. You should be like I tell you that you need to know to. Well, you know, there are so many different variations. Like you have to know those putative questions, those sort of typical archetypal questions, those first two that we did, and be able to apply them in different scenarios. I could also give you a question. I don't know where it is exactly, but I could give you a question where that's a mountain, right? Where it lands at some distance away. Now, I'd have to give you some information. Like, I would have to give you the angle. Let's say it's 30 degrees. I would give you V naught. Say it's 20 meters per second. And say I give you the distance away. I might have to change this number. I'm making it up now. Let's say it's 30 meters. And I ask you, what is this y height? What is y equal to? Could y'all do that? Okay, well, in this one, I know that y is equal to v naught y times t plus 1/2 ay t squared. And so in order to solve this, I would have to find t, because I know v naught y. V naught y is 20 sine of 30. It's 10. I know ay is negative 10, but I don't know t. So I need to find t. And so that's sort of the hard part on this, is finding out what is t. How can I find t? Right, we did this one before, right? I say x is equal to vxt and then I can solve for t. Because I know the x displacement, it's 30. I know vx, it's 20 cosine 30. And I solve that for t. And so that's 1.7 seconds. I'm pretty sure I gave this on an old test at some point. So t at this point is 1.7 seconds. And then to find y, I just take that t. Say y is equal to 10, that's this value, times 1.7 minus 5, that's half of a, times 1.7 squared. And if my numbers worked out, I should be okay. That's 17 minus. I get point, oh shoot. It was equal to 0.55, I think. This was 14 point, and you're right, 2.55. So this distance is 2.55 meters. That's a type of problem that you can see too. Now you're not going to see a whole bunch of these funky problems, but you probably see at least one or maybe even two. Okay? Kira? Can you repeat
Was that
yourself?
that was one where we did have to do quadratic.
You're not going to do the quadratic equation on the test. You have to do it on the OpenStax, but not on the test. You're not going to have to solve two simultaneous equations. That is where you have to substitute one equation into another. But you do that on the OpenStax. Dominique, if you want to sign in up here. Yeah.
So the reason we didn't have to have the time is because y isn't where it's at its max time.
That's right. Yeah. So, right. Right. She said the reason we didn't double or halve the time is because we're right here, not right here. Like this time, we could figure it out, but we don't know what it is. We can't do anything with 1.7 to find the time at the top of the trajectory. Okay? Any other questions, or we'll dismiss? But we're going to have help sessions every. Wait, don't forget it, because there might be other questions. I want to deal with them. Listen, if you're feeling overwhelmed and lost, come see me. I spend this week, gosh, it feels like I spent about 12 hours in my office with students, and that's okay. Like that's why they pay me lots and lots of money to help y'all. Did y'all know they pay me a lot to help y'all? And I like to see you do well in the class. It gives me great joy. And if that means that we have to sit down and sort of go through and see where your weaknesses are, or even just to give you a kick in the right direction, then that's my job. Okay, so let me do my job. In fact, that's all of your professors' jobs. And if you don't feel comfortable doing that, go in their office and demand it. And say, I demand you to help me. And then see how that gets for you. So say it in a diplomatic way, but that's our job to help you. And we want to help you, almost all of us do. Okay? Great day. I'll see you Monday. Have a good weekend.